This little toy is called a drinking bird. You put a cup of water in front of it and its head dunks into the cup. Eventually the head bobs up again, but then it goes right back into the water. If you don't know much about thermodynamics, the drinking bird might seem like it could go on forever without an external source of energy powering it. A perpetual motion machine, in other words. But the toy isn't a perpetual motion machine because perpetual motion is impossible according to the laws of physics. One of the reasons is the first law of thermodynamics. One of the main goals of thermodynamics is to describe the transfer of energy. We've already described two processes as a transfer of energy, work and heat, and they're both connected to each other. As a thermodynamic system does work, it loses heat. When work is done on a system, it gains heat. So heat is converted to work, and work is converted to heat. So this idea that the change in internal energy is equal to the change in work plus heat is so fundamental that it's known as the first law of thermodynamics. So we can have an equation to use for analysing problems. We write the first law like this. The internal energy, U, of a closed system is equal to Q, the heat transferred to the system, minus W, the work done on or by the system. It's important to remember that when we talk about changes in internal energy, if heat is transferred into the system, Q is positive, and if heat is transferred out of the system, Q is negative. And if work is done on the system, W is negative, and if work is done by the system, W is positive. Now you'll notice that the first law of thermodynamics describes only those two factors, work and heat, as affecting a change in internal energy. That's because as long as the system is closed, meaning it's isolated from the rest of the universe, there just aren't any other factors involved.